Practice test, gonna solve the practice test. All right, let's do it. Problem number 1. So, if you notice, it says right here, ignore friction. That's just something I love to highlight in problems. And when you ignore the friction, that means there's no dissipated energy. So what's going on here? We have this cart that starts off with all elastic energy. There's no kinetic and no gravitational. And then, pew, it gets fired up this loop all the way up here. And all that energy gets converted into a combination of kinetic and gravitational. Now, we're not going for accuracy or scale here. So if you have any friends or family, you know, that are engineers, like if your mom looks at this and she's like an engineer for Boeing and she looks at what you're doing here, she's going to tell you this doesn't really represent an accurate bar graph. She's right. The fact is, though, we're not trying to do super specific bar graphs here. All I'm interested in is, did you label where the energy goes? And the fact is, it starts off as all elastic, and it gets converted into a combination of kinetic and gravitational. Woohoo! So now we can just go ahead and calculate that out. When we go to our formula sheet, we have the elastic energy is 1/2 kx squared, and that gets equal to 1/2 mv squared plus mgh. Let's go ahead and plug in our numbers. So we have 1/2, 120, and then x squared is 2.5. We'll square that, and 2.5 squared, and that's going to equal 1/2. Our mass is 5. V squared is unknown, plus m 5, g 10, h, which is 6. And so when we actually work this out, we're going to end up getting v is the square root, I believe, of 75. When we actually work this math out, we end up getting 5.5 meters per second, like the square root of 30. All right, so that is problem number 1. Now, when we move on to problem number 2, let's be clear. Notice we have no gravitational energy because the height is 0. We do have kinetic, so it's all kinetic energy. We are moving. And then we hit the spring, and the spring compresses, and it becomes all No, not all dissipated, because there's no friction. So there's no dissipated energy. No dis. It becomes all elastic energy because the spring's compressed. So when we set that up to get the maximum compression of the spring, let's do it. We got EK equals, ew, gross. Let's try that again. EK equals elastic. So we got 1/2 mv squared is 1/2 k x squared. Let's put in our numbers. 1/2. M is 8. V squared, that's 5 squared, equals 1/2. K is 50. X squared, oh my goodness. So we're going to end up getting x is, well, let's just multiply this out. So we're going to end up getting 4 times 5, that's 100, equals 25x squared when we do all our math. Let's divide both sides by 25. Pew, pew. We get 4 is x squared. And when we take the square root of that, x is 2 meters. So exciting. So that's page 1 of your practice exam. I'm going to record page 2 in a second.